Hello, so welcome to the last session of the production process. In this video, we are going to look at the determination of the firm's equilibrium. So this is the long run production part 3. So let's begin by looking at the ISO cost. So the word ISO means equal. So the term ISO cost line means equal cost line. In other words, an ISO cost line shows the different combinations of two factors that the firm can buy given the firm's total outlay and the factor prices. So when we're talking about total outlay, we are talking about the total cost. So what happens is that the firm is considering to buy the factor inputs. Let's continue with our assumption that we are only using two inputs, that's capital and labor. Then it means that for each capital that the firm brings in, there should be an associated cost of buying that capital. And the labor that the firm is bringing into the production process has the cost that is associated with it, which we will call the cost of labor or wage. Now, it is these two items, that the cost of labor and the cost of capital, that brings about the total cost of the firm. When we have all the amounts of capital and all the amounts of labor that the firm is bringing into the production process, then we will have the total cost for the firm. As such, the ISO cost line is represented by the equation C equal WL plus RK, where C is the total cost of purchasing the inputs. W is the wage or the price of labor, how much you pay to get the labor. So remember now, when we are looking at this cost, we've moved away from the goods market. We are now in the labor market. And when we are looking at this part here, we are in the capital market. In other words, what we are looking at here is the factor market and not the goods market. Our L is the amount of labor that the firm is bringing into the production process. And the R is the rent or the price of capital. It is also called the interest. So in other words, we are calling it rent here to mean how much you pay to use the capital. K is the amount of capital that the firm is bringing into the production process. If we look at the whole term WL, we are looking at the total payment for labor that the firm makes. So this part here is the total cost that is coming from labor alone. The other part, which is RK, is the total payment for capital, meaning how much the firm is paying to acquire the capital. In the case of the two inputs, that's labor and capital, the ISO cost line shows the different combination of capital and labor that the firm can buy given its outlay and the price of capital, that is rent, as well as the price of labor, that is the wage. Now with this, I urge you to go back and look at the theory of the consumer, where we looked at the budget line and see the behavior of the budget line. So you will notice some similarities, and these will help you understand the determination of the firm's equilibrium. So the ISO cost plays an important role in determining what combination of factors the firm will choose for production. So given the capital and the labor, and given the prices of these inputs, the ISO cost line will give us the different combinations of the capital and labor which will have the same cost. Now, in understanding the ISO quant of the firm, we will be able to bring the ISO cost and the ISO quant together and then determine the firm's equilibrium. So more formally, the bundle of inputs L and K are affordable if the cost, which is the cost of the inputs, is greater or equal to the summation of the cost coming from labor and that coming from the capital. In other words, the bundle of inputs is affordable if the sum of the payments to the factors is less or equal to the total cost. Here we note again that W is the wage or the price of labor, and R is the rent or the price of capital. And C should also be understood that this is the expenditure that the firm is making in acquiring the capital and the labor. So with that, then we add on that the bundle exhausts the firm's budget if expenditure strictly equals the budgeted cost. That is, if we have an equal sign in the equation. So we have the payments that the firm is making on the two factors, and then we have the total outlay that the firm has to make, or the expenditure that the firm has to make in acquiring those inputs. Now, if there is an equal sign here, it means then the firm is exhausting the entire budget for the inputs. As such, the above two equations that we have, which is this one with an equal sign and the other one with an inequality, forms the firm's cost constraint. In this case, then it should also be noted that the firm aims at maximizing output subject to the given cost. Now let's consider the cost constraint WL plus RK equal to C, where in this case we are dealing with an equal sign. If we make L the subject of the formula, what we get is that L will be equal to C over W minus R over WK. Now this is similar to the one we looked at in the theory of the consumer, where this was the income and this was the price of commodity X, and this was the price of commodity Y, and this was Y here. Well, L was X. If you look at it in that way, it means that what we have down here first here forms the horizontal intercept. This ratio here is the horizontal intercept. Okay, so, and if we make K the subject of the formula, we end up with this equation. Again, to be noted here is that this ratio here is the vertical intercept. Then the other part that we have here, negative W over R, is the slope of the ISO cost line. With this in mind, it means that we can draw our ISO cost line. So on the vertical axis, we put capital, and on the horizontal, we put labor. Now, since the ISO cost has a slope which is negative, it means that it will be downward sloping. From here, we can define our vertical intercept, which is C over R, and our horizontal intercept, which is C over W. Recall that the slope of the ISO cost line is a negative W over R. Let's take an example with numbers so that we see how this can be plotted. So if L cost 10 per unit and K cost 5 per unit with a total outlay of 1,000, number one is that the cost constraint then can be written as 10L plus 5K equal to 1,000. So this is the W and this is the R. So in our equation, if you remember, it was WL plus RK. And this is equal to C. So from here, this is the W, this is the R, and this is the C. So with that, then what we have is that if we make K the subject of the formula, we end up with the equation K equal to 1000 divided by 5 minus 10 divided by 5L. So simplified, we have K equal to 200 minus 2L. So it should be noted that what we have here, this 200, is the vertical intercept. Okay, so if y is equal to, so this is supposed to be K. So if K is equal to 0, then L will be 100, which means that then what we have is the horizontal intercept. So if we draw this diagram, we have the 200 on the vertical and 100 on the horizontal. The slope is -2, so this -2 here is the slope of this isoquant. The isocost line. Okay, so now let's look at the changes in the outlay as well as the factor prices. Now, a firm is in equilibrium when it maximizes output for the given total outlay. Now, given the total cost, the firm must reach the highest isoquant and be able to maximize output. So in other words, the firm will only maximize output if the isocost line and the isoquant are tangent to each other. Okay, so now let's look at the equilibrium in detail. So changes in the total outlay alters intercept of the isocost but does not change the slope. This is similar to the budget line. I'll keep referring to that because we looked at these curves and how they are moving. So what we'll be doing in here is just more like a recap, but looking at it from the firm's perspective. So if we change the total outlay, which is the expenditure planned by the firm, we'll end up changing the whole intercept, but the slope will not change, because this will be the shift in the isocost line. So the reduction in the outlay will shift the isocost line inwards, and the increase in the outlay shifts the isocost line outward. Note also here that changes in the factor prices holding the total outlay constant causes the isocost line to rotate at the intercept of the factor with the unchanged price. Now this may sound too technical, so let me just try to illustrate here. So we have this isocost line. So when we say changes rotates at the intercept of the factor with the unchanged price, we're talking about this intercept here where the price has not changed. So it will be rotating. This part will become the pivot. Okay, so an outward tilt for a factor will mean that the price has reduced. Okay, so outward for a factor price will be a decrease. Then an inward, the outward movement will be for a decrease, and inward if the factor prices have increased. Okay, so now a firm is in equilibrium when, given the cost outlay and factor price constraint, the firm is maximizing output. Now, how does the firm maximize output? A firm is in equilibrium when, given the isocost, the firm reaches the highest possible isoquant. Thus, the firm is in equilibrium if the slope of the isoquant is equal to the slope of the isocost line. With this, consider the choice principle for the firm then will require that the firm chooses the highest ranked available options. And from there, it means that the firm will choose a bundle on the ISO cost line and not below it, and a bundle on the highest ISO quant that touches the ISO cost line. Okay, so let's have an illustration. So on the vertical axis, we have capital, and on the horizontal axis, we have labor. So if we have indifference curve 1, indifference curve 2, and indifference curve 3, so remember, we call these production indifference curves. So these isoquants are production indifference curves. So if we have the three of them, then the firm has to choose the highest possible isoquant where it can produce, and that should be a point where the ISO cost line is tangent to. If we draw our ISO cost line, we notice that we have the point of tangency here. So on the vertical axis, we put the intercept, and on the horizontal, we put the associated intercept. The point of tangency here, we can call it point E, becomes the equilibrium point. And from this point E, we see that the slope at that point, which is the marginal rate of technical substitution of labor for capital, is equal to the negative of the factor price ratios. So we conclude that the firm maximizes output at point E, and that the firm is in equilibrium at point E. Now, these are the convex isoquants. We can also look at the case of the right-angled isoquants. Now here again, we see that the firm is in equilibrium at point E, and the direction of increasing output level is up and to the right. So the firm maximizes output at point E because the ISO cost line is tangent to ISO quant 2. So at point E, the marginal rate of technical substitution is equal to the factor price ratios. So with that then, equilibrium condition is that the marginal rate of technical substitution of labor for capital must be equal to the marginal product of labor divided by the marginal product of capital with a negative, and this must be equal to the negative of the factor price ratios. Simplified, it means that what we'll have is that the marginal product of labor divided by the marginal product of capital must be equal to the factor price ratios. Now you will notice that there are no negatives here, because if we get this part alone, this part of the equation alone, you will notice that there is a negative here and there is a negative here. So it means the two negatives can cancel, leaving the equation without negatives. Therefore, the condition for equilibrium is that the marginal product of labor divided by the marginal product of capital must be equal to wage divided by the rent. Or simply put, what we will have then out of this is that the marginal product of labor divided by the wage must be equal to the marginal product of capital divided by the rental price of capital. So all we've done here is we've just done a rearrangement. So if you cross multiply and then you divide, you will notice that this is what you end up with. So we can do that here. So for those who may get confused, so if you cross multiply, you will have a marginal product of labor, divided by the rental price of capital, and this is equal to the marginal product of capital divided by the wage. So here I'll divide by wage so that wage here disappears. So meaning even here I'll divide by wage. So wage will come this side. Then next I'll divide by R so that this R, there will be another R down here, disappears, and this R will come here. And you will notice that this equation will be similar to what we have here. Okay, note that if the marginal product ratio of the marginal product of labor to the price of labor is less than the marginal product of capital divided by the price of capital, or the other way around, then the factors are not being efficiently used. The producer then will have to substitute the input in order to reach the point of equalization. Now, which direction do you think in the first case, if this is the case, how will the substitution of labor and capital be? Which input will be brought in and which input will be released? I leave this as something that you'll have to think about and then be able to understand what is happening. So you should also think about the other part here. Okay, let's look at allocative efficiency. Now, when we are looking at allocative efficiency, we try to ask if the firm is using the least cost combination of the inputs. So given all the combinations that the firm has, we want to find the least cost way which we can produce a given level of output. Now that then should satisfy this equilibrium condition that we saw in the previous slide. That means that if the firm manages to satisfy this equation, it means the firm is achieving allocative efficiency. Then the other one is a technical efficiency. Now here we want to ask if the firm is maximizing the potential output from a given set of inputs. So given this diagram, then what we are asking is when a firm produces at point T, which is here, rather than point D, which is a point of equilibrium, on a lower isoquant, then the firm is not producing as much as it as much as it can produce if it was to be technically efficient. Therefore, for a firm to be technically efficient, we want it to maximize potential output from any given set of inputs. Thank you very much for watching. See you in Unit 9, where we're going to look at the cost of production. If you have questions, send an email to moaoelias@gmail.com. Bye-bye.